Bismillahirrahmanirrahim. Assalamu alaikum everyone. In this video tutorial, I'm going to talk about multiplication of two numbers in x86 assembly. So we are going to discuss multiplication instruction, and we will see uh, also it's some example. Let's say there are two numbers which will be input by a user num1 and num2, and we will multiply these two numbers, and then result we will store in another variable, let's say result or the product. Okay, but before we go and use this multiplication instruction, we need to understand how multiplication instruction works. So in x86 assembly there are two mul instruction. One is mul, another is I mul. So what is difference between the two? Mul is basically used for unsigned numbers, like for example, unsigned numbers 0, 1, 2, 3 and onwards. Okay. IML is used for integers. Okay. Like uh, +1, -1, +2, minus 2, and so on. This is the key difference between mul and IML. But rest of the multiplication, rest of the procedure or the syntax almost similar. So how does mul command actually work? Mul instruction assumes that your first number or any of the two number which are supposed to be multiplied is stored in AX. Okay, so one of the numbers must be stored in AX or standard AX if we are talking about 32-bit registers. And the second of the numbers may be stored in register. So any other register slash memory. And memory means variable in x86. Okay. So uh, once one number is stored over here in EX register and the other number is stored in another operand, then we can use the mul command. And how we gonna use? Simply mul and the other operand, which may be register or memory. Okay, so there is no usage of AX here or accumulator here, because it is quite understood that mul is going to use. Okay, so the first operand will be stored in accumulator or extended accumulator, and the second operand may be stored in register or the memory. And then we will simply use mul register if the second operand is register, or mul memory if the second operand is the memory. So this is the procedure how mul command actually works. Okay, so this is the explanation of mul. And remember, there are two instructions, mul and imul. Both are similar. The only difference is that mul is applicable to unsigned numbers and imul is applicable to integers. Okay, so let's proceed to our example. Okay, in our example we will ask user to enter two numbers. So we will create two prompt messages. Let's say prompt 1, and it will be byte type, and it will be enter the first number. Okay, and comma 0, which is a terminator. And we will also use another prompt message in which we will ask the user enter the second number. Okay, and there will be another prompt message which will say that the product of the two numbers is. Okay, so it will be our third prompt message. And we will create some variable as well, because it is always good practice that whatever the number is being received from the user, you can store them in data memory. So let's say we create num1, which is the d word. Remember, d word is used for unsigned number. Okay, num2, d word, and product is a variable which will store the result, d word. So all those are what? D word type or unsigned double word. Okay. So that's it from the data memory. So let's start the code. So first of all, we will print the first prompt message, and how we can do so, we will have to move the first prompt offset uh, into the DX register. And how you can do that, EDX comma offset prompt 1, and then we simply call write string. I hope you have been following my tutorials about x86 programming, and I have already done the code of hello world in which I have just printed the hello world or any string. So if you don't know about this offset thing, then you must follow that video tutorial, and I hope this thing will become very clear. Then we will simply take input from the user, and remember those are unsigned numbers, so we will use call read decimal to read the decimal number uh, or unsigned number from the user. Okay. And of course, whenever we use read decimal, the result is stored in AX register. So let's say we will move the value of AX register into num1, num1 comma EAX. It will keep the value of accumulator into the num1. Then we will repeat the same procedure. So I will just copy and for what? For the second number. So move EDX prompt, instead of prompt 1, it should be prompt 2, and it will be num2. So now the two numbers are stored in num2 and num1. Now we're gonna multiply. So if you remember, the one number should be stored in what? Accumulator, and the second operand can be used either in register or in memory. So if you notice that num2 num2 is already available in AX register, so I can simply write what? Mul num1. Num1 means the memory. Okay, num1 is the memory location which is holding the value of the num1, and num2 is already present in accumulator. So this instruction will force what? The value of accumulator, which is basically what? Num2 multiplied with num1, because we have been using the operand over here is num1, and then the result will go to what? Will go to register dx comma ax, or if in case of x86 it will be edx comma eax. Okay. Okay, here question arises, why to register? The answer to the question is very simple. Whenever you multiply the number, it is quite possible that number of bits may uh, increase from the original numbers. Okay, the very simple example is 3 multiplied by 3 and result is 9. So if you check them in binary, those are basically 1 1 multiplied by 1 1, and result is was 1001. So it's quite possible that 2-bit number multiplied with a 2-bit number result is in 4-bit number. So that is why when two 32-bit number num2 and num1 are being multiplied, result will go to 64-bit. That is why 32-bit lower 32-bit will be stored in accumulator, and higher 32-bit will be stored in uh, data register or EDX register. Okay, so I hope this point is clear. But of course, in this example, I will be using some numbers like 5, 400. For these numbers, it is very their product can be stored easily in EX register. So I will use just EX register to get the result. Okay. So what I will do, move prod comma EAX. Okay, just to bring the result into the prod or prod variable. Okay. Okay, now we will print this prod as well, and we know that prod is already available in what? Extended AX register. So we can simply write call write decimal. Remember, earlier we were using read decimal because we were taking input from the user, and now what I'm doing, write decimal, so it will simply print the value of accumulator onto the screen. So this program should work. Okay, so the thing which I've just explained in the very last, I will just comment them before we go and build it. It is the just explanation of multiplication instruction. So I guess now we are ready. So let's build the code. Yeah, it says build 1 succeeded, 0 failed. That means we are good to go and good to run this code. So let's run the code. So if I'm going to run this code, it gives me this prompt message. So let's say it is asking me my first number. So let's say 5, and the second number is 4. And if I press enter, the result is 20. Okay. If you remember, we have also written down the third prompt message, which was prompt 3. So we can simply, in the last, before printing the result, we can simply call that prompt message. It was prompt 3. So what I'm doing, moving the offset of prompt 3 in data register and simply call write string, and then we simply write the accumulator value. So what will be the change? Let me build it. Build it successful. Let's run the code. Yeah, it is asking my first number 5, the next number 4. And if you see now, the third prompt message is also printed. Product of the two number is 20. Okay. Let's try this code again. Let's say value first number is 2, second number is 10, and answer is 20. That's great. But what if, let me try the different value. I want to explain something. So let's say if I'm gonna use some negative number, it's minus 4 multiplied by 5. Answer should be minus 20. So result is what? 0. So that means my negative numbers are not working. Let's test it again. So minus 2 multiplied by minus 8, and result is again 0. So that means my code is not working for integers or negative values. So what can I do? In what should be the change? First of all, instruction. Instruction should be used imul. Okay, that should be the first change. Okay, and what other thing? Wherever we use decimal, it should be integer. Read integer and read integer, and in the very last it was write integer. One thing more, which is very important. Earlier, when we were defining these memories, we used the double word data type, which is unsigned. So we will make it signed double word, signed double word, and signed double word. So that's the change we should make, and it should work for the negative number. So let's see if it is going to work or not. First of all, let's build it. Yeah, it is successful and without any error. And then we simply run the code. So this time I'm going to test it for the negative number as well. So minus 5 multiplied by 4. Answer is minus 20. Yes, correct. The product of the two number is minus 20. So let's say if I'm going to run it another time, let's say minus 4 multiplied by minus 8, answer is plus 32. So you see, this is the key difference between the mul and the imul, which I explained you earlier. So I hope you have understand this video tutorial in which I've just explained how multiplication instruction works, and furthermore how you can take two numbers from the user and process them in your code and print their result. Okay, so you can use this tutorial as a sample tutorial or sample program, and you can run any arithmetic instruction like plus, divide, minus, and so on, right? Not only the arithmetic instruction, you can also check for logical operation like AND, exclusive OR, and NOR. Okay, so I hope you have understand this video tutorial. Still, if you have any confusion, you can post your queries in comment section. Thank you so much for listening.